Simple molecular structures. This is the structure that define that what is actually present in molecules. There are substances which are in molecule form, such as water, carbon dioxide, carbon monoxide, methane. You can say that any covalent substances, they have molecular attraction. The molecular attraction is the force that is present between molecules. I repeat, the force of attraction present between the molecules is called intermolecular force of attraction. Won't you write? Please write. Force of attraction present, force of attraction present between molecules called intermolecular force of attraction. The force of attraction present between molecules is called intermolecular force of attraction. All right. Now I want to show you that what is this intermolecular force of attraction by drawing a diagram. For example, let us draw a molecule of water. Okay, a simple molecule of water. Water consists of, oxygen, bond hydrogen, hydrogen. So this is a molecule, single molecule of water. This is a single molecule of water. Okay, or I can circle like separately. Now look at this. This is a single molecule of water. There is covalent bond. You can see this is covalent bond between oxygen and hydrogen, and between oxygen and hydrogen in both sides. This is hydrogen atom, this is oxygen atom, and this is also hydrogen atom. And this is a molecule. Now, this is another molecule. This is one molecule. I can write for you. This is one molecule of water. This one is one molecule of water, and this one is another molecule of water. And like there are other molecules here, another molecule here, another molecule here, another molecule here, for example. Okay, and there are always everywhere, that is like this is hydrogen, this is oxygen, this is hydrogen, hydrogen, oxygen, hydrogen, hydrogen, oxygen, hydrogen. Now this is one molecule of water, this is another 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 molecule of water. In each molecule, covalent bonds present. In each molecule, covalent bonds present between hydrogen and oxygen. In each molecule covalent bond present between hydrogen and oxygen, which is very strong. Which is very strong. We cannot break this covalent bond easily. Not possible. It's not easy work. Now, this molecule and this molecule, they have very weak force of attraction present. Look at this dotted line. Dotted line means very weak. This molecule and this molecule have very weak force of attraction present. This one and this one. Everyone has everyone. Everyone has force of attraction with everyone. This force of attraction is very weak, remember. When we give heat, this force of attraction breaks. When we heat water, this force of attraction breaks and water becomes steam. Water becomes steam because now the molecules are in a force of attraction and they are together in a container. When we give heat, these dotted lines, which is called intermolecular force of attraction, it breaks and molecules become separate and they go further apart individually, and we say that water becomes steam. So when we give heat, this intermolecular force of attraction, it breaks. So this is molecular force or intermolecular force of attraction. Force of attraction present between molecules. Between molecules. And force of attraction present inside the molecule of water, it is covalent bond. What I said? Force of attraction present inside the molecule. Force of attraction present inside the molecule of water. Inside the molecule of water between atoms, and it is covalent bond. It is covalent bond. And force of attraction present between the molecule, not between the atoms, in the molecules of water. This is intermolecular force of attraction. You must have to write down these notes. These are very important notes. All right, very basic and important notes, what I'm writing, because students mix up between covalent bonds and intermolecular force of attraction. They mix up. They think that both are same. Actually, both are not same. Covalent bonds present between atoms inside a molecule and intermolecular force of attraction present between molecules. Covalent bond is stronger. Intermolecular force of attraction is weaker. Small heat can break intermolecular force of attraction, and that's why water at a very low temperature, water becomes steam. Due to this weak intermolecular force of attraction, at room temperature, oxygen, hydrogen, carbon dioxide, these are gases. Very important line I said again. Due to this weak intermolecular force of attraction, room temperature, oxygen, hydrogen, carbon dioxide, carbon monoxide, chlorine, ammonia, methane, ethane, sulfur dioxide, etc. are gases. The thing is that they are gas at room temperature. Why? Why they are gas at room temperature? Why not they are liquid? Why not they are solid? Why they are gas? Because the force of attraction or weak intermolecular force of attraction present between them, this force is so weak that heat energy at room temperature, heat at room temperature can break this intermolecular force of attraction. And the oxygen present in our atmosphere, the molecules are free. The molecules are free from each other. There is no force of attraction because the force of attraction is already broken due to this atmosphere temperature. And you know, room temperature in science, room temperature, especially in chemistry, room temperature is considered all over the world 25 degrees Celsius. Room temperature is considered all over the world 25 degrees Celsius is called room temperature. Room temperature does not mean the temperature right now you are sitting inside a room, the temperature of that room. It doesn't mean that. It is a laboratory temperature. Its name is room temperature and it is 25 degrees Celsius. We cannot change it. It's not like that you are sitting inside a room and temperature is 30 degrees Celsius. You are in AC room and the room temperature is 20 degrees Celsius. Not like that. Room temperature is fixed 25 degrees Celsius. And this is a laboratory temperature. You will be knowing more about it in future. So this is all about intermolecular force of attraction and the substances in which intermolecular force of attraction present are called molecular substances. Another line. The substances in which intermolecular force of attraction present are called molecular substances. An example is given here. I already wrote the examples here. Look at this. These are the examples. So the substances in which intermolecular force of attraction present are called molecular substances. And their structure is called molecular structure. And their structure is called molecular structure. This is a very important topic today. Early in the morning we read. We read molecular force of attraction or intermolecular force of attraction. I have shown you here detailed diagram of water, that this is one molecule of water, this is another molecule of water, this is another molecule, this is another molecule, this is another molecule. And each molecule, there are 2 hydrogens and 1 oxygen. Why? Because the formula of water is H2O. That's why each molecule contains 2 hydrogens and 1 oxygen. And inside the H2O, the force of attraction between hydrogen and oxygen is covalent bond. It is written here. This covalent bond inside the molecule. This is called one molecule, H2O. So hydrogen and oxygen, they are in covalent bonds, and one molecule to another molecule, look at the dotted lines, that is called molecular force of attraction or intermolecular force of attraction, and which is very weak. Covalent bond inside the molecule is very strong. Molecule to molecule intermolecular force of attraction, it is very weak. At room temperature, which is 25 degrees Celsius, this molecular force of attraction breaks and water becomes steam. That's why at room temperature, many other gases such as oxygen, hydrogen, carbon dioxide, carbon monoxide, chlorine, ammonia, methane, ethane, sulfur dioxide, phosphine, propane, and there are other gases, hydrogen chloride, hydrogen bromide, fluorine. These are all in gaseous form because they have weak intermolecular force of attraction between the molecules, which already broken due to the atmosphere or room temperature, or room temperature. And the substances in which intermolecular force of attraction present, these substances are called molecular substances, and their structure is called molecular structure or called simple molecular structure. I think that you already written these notes or you got already screenshots. So I return back to textbook. So simple molecular structures, these things we already read, and this is the example. And there are many other things are written here. Look at this. So what the things are written here, I expect you to read from textbook so that you can make your ideas more clear. And here, substances with simple molecular structures tend to be gases mainly, or liquids or solids sometimes. There are some substances which form liquid or solid. Low melting and boiling points. They have low melting and boiling points, remember. The reason is that not much energy is required. Here is the reason. Not much energy is required to break the weak intermolecular force of attractions between molecules. Remember, no covalent bonds are broken. Covalent bonds are strong. So this is a very important paragraph. Very important paragraph. Now look at this. This is liquid water. And this is gaseous water. Water becomes steam. There is no force of attraction between the molecules. Melting and boiling points increase as relative molecular mass increase. Look at this. Fluorine, chlorine, bromine, iodine. These are all group 7 elements. According to the arrangement of periodic table, the arrangement is here. Fluorine, chlorine, bromine, iodine. They are all diatomic. And their molecular mass of fluorine is 38, then increased to chlorine, then increased, it is bromine, then again increased, it is iodine. So as molecular mass increases, melting point and boiling point also increases. So very important line, the melting point and boiling point increase as relative molecular mass increase. And relative molecular mass, how to find it out? You know the periodic table, like F2 equals to, in periodic table, you will get the relative atomic mass of fluorine, and the relative atomic mass of fluorine, it is approximately 18.5. 18.5. So here there are 2 atoms in one molecule. So multiply 2 equals to, it is actually 19. I'm sorry, 19. So it becomes 38. Chlorine, Cl2. It is 35.5 is the relative atomic mass that you know. We read relative atomic mass. It is given in periodic table. So 71 is the relative molecular mass. This is the relative molecular mass, how it came out. For bromine, if you go to the periodic table, you see that bromine relative atomic mass of bromine is 80. Multiply 2 because there are 2 atoms in one molecule, so 160. And for iodine, it is 127 multiply 2 equals to 254. These values you will get in periodic table. It is given in periodic table, the relative atomic mass. Please, after this class, open your periodic table and match it. Page number 320 Periodic table is given in page number 320. So melting point and boiling point increases as the relative formula mass increases. All right. So very important table. So this is mentioned here again. The boiling points increase down this group, which means we have to put more energy to break the intermolecular force as the relative molecular mass increases. This means that the intermolecular forces of attraction must become stronger as relative molecular mass increases. The general, very simple discussion that as boiling point increases, it means that you need to put more energy, heat energy, to break the force of attraction between the molecules, because the molecules become heavier, their relative molecular mass increased, and so their intermolecular force of attraction becomes stronger. So when relative molecular mass increases, intermolecular force of attraction increases. Very important line, right? Can we write here it? You can write it here. When relative molecular mass increases, intermolecular force of attraction increases, and melting and boiling point of substance increase. When relative molecular mass increased, intermolecular force of attraction increase between molecules, melting and boiling point of substance also increase. Look at this, some other physical properties of covalent compounds. There are some other properties of covalent compounds given here. Covalent compounds, they do not conduct electricity because there are no free ions or free electrons in their structure. Covalent molecular compounds, so far we read, covalent molecular compounds do not conduct electricity because they do not have any overall electric charge. They do not have any overall electric charge. They do not have any free ions or free electrons which can move and conduct electricity for them because they do not have any overall charge. No free ions, no free electrons. That's why covalent compounds do not conduct electricity. Covalent compounds tend to be insoluble in water. They are insoluble in water. There are some exceptions. Look at this. Ethanol is an exception. Ammonia is another exception. And hydrogen chloride gas. This is another exception. Otherwise, covalent molecular substance, generally, they are insoluble in water. Now we will read giant covalent structure, that is diamond. Diamond is a pure form of carbon. Diamond is pure form of carbon. Look at this structure of diamond. This is the diamond that people used as jewelry. The jewelry ornaments, famous ornaments all around the world made by diamond. This is that diamond that we are studying here. So all are carbon atoms. This one is carbon, this one is carbon, this one is carbon, 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 carbon. carbon atom, carbon, 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 and there are more. This is small part is drawn here. There are more. So this is the structure of diamond. All are carbon, and it's pure form of carbon. Look at this. It's the pure carbon. And each carbon is covalently bonded. This is covalent bond. Each carbon is covalently bonded with 4 other carbon atoms. And it's a tetrahedral arrangement. It's a tetrahedral arrangement. Each carbon is covalently bonded with 4 other carbon atoms strongly. Tetrahedral arrangement. Each carbon is covalently bonded with 4 other carbon atoms. There is no electron free. There is no electron free in its structure, and that's why diamond does not conduct electricity. And it has high melting and boiling points because strong covalent bonds present between carbons, and many carbons together make the structure stronger. That's why diamond has very high melting and boiling point, and it is considered as the hardest substance in the world. And I repeat, many atoms together make the structure a giant structure. Lot of energy required to break these strong covalent bonds. Diamond has very high melting and boiling points. Very high melting and boiling points. Strong covalent bonds, many atoms together make the structure giant and more stronger. It's considered as the hardest substance in the world. It's very hard. It does not conduct electricity because there is no free electron in its structure. All right. This is diamond, you can see. But this is the thing that we see in our open eyes. And this is the structure. It is microscopic view. Microscopic instrumental view.